Okay, so in step one, there's no grouping symbol, so I'm going to go ahead and combine my like terms by moving my x's to the right. I'll subtract a 3x from both sides, leaving 4x. At the same time, I can move my constants over to the other side. So if I subtract a 9 from both sides, I get negative 17. And so my final step is to isolate my x completely. And so I get a negative 17 over 4. Okay. B is a little more challenging. Okay. In this one, the variable that I'm solving for is x. I still need to do all the same steps in the process that I did for any other linear equation. Okay. Combine my like terms. So I'm going to move all the x's to one side. I'm going to subtract a bx from both sides, and at the same time move my constant to the other side by adding 6 to both sides of the equation. So that gives me 2ax minus bx is equal to 1 plus 6, or 7. And I still need to isolate my variable. Now, it's a little bit tougher to do in this situation, but it can still be done. What allows you to isolate your variable x? How do you take the x out of both of those terms? Yeah, it's factoring. So we're going to factor out our x. That leaves a 2a and a minus b. And then to isolate the x completely here, we undo the operation. So we're going to divide by that binomial, 2a minus b. And we get our solution, x is equal to 7 over the whole binomial, 2a minus b. Okay, and then the final example, again, as you work through this, if we distribute and get rid of our grouping symbols first, have a 5x equals 2x, a minus 1, a minus becomes a plus 3x. Notice what happens as I start to combine these. 2x and 3x gives me a 5x minus 1. And when I work to subtract a 5x from both sides, I wind up with 0 is equal to negative 1. Now, that's different than the identity, right? In the identity problem, 0 is equal to 0, and that's a true statement. But is this a true statement? Is 0 equal to negative 1? No. So what that means is there is no solution that works for this, okay, which is a possibility. An answer for solving an equation could be no solution.